Hi, and welcome back to Nordic Testing Day 2021. I hope you had a great lunch. We had a good lunch here, so hope you had the same. Our next speaker is from the UK. Thomas, are you there?
I am indeed. Hey,
Hi, how are you doing?
I'm good, thanks. How are you?
Great. So you will be talking about consumer-driven contract tests and microservices. I was trying to make sure that I don't mispronounce any words.
It's a definite struggle as you go through the slide deck.
Yeah. So yeah, no long introduction needed from me. So take it away.
Absolutely brilliant. Thank you. Okay, well, thank you for coming to my presentation. I'm not sure, am I meant to be sharing the slides from my computer? There we go. There's the slides. Brilliant. Cool. So yes, my name is Thomas Shipley, and today I would like to talk to you about relationships, and specifically the relationships that form between the microservices that we develop and how important it is that we test them. So if I try my little clicker. So I'd like to start with a question. And that question is, why are social networks so valuable? Why is it that Facebook, LinkedIn, Twitter, all these companies are worth so much money, and why do advertisers pay so much money to advertise on those platforms? And I believe the answer is relationships. The key with these platforms is, yes, you may have some personal data attached to you as a user, but it's only when you start to form relationships with other users that there really starts to be valuable data. Your likes, your interests, your family, your friends, where you live, communities, all that data is modeled by relationships. And so that's what really gives the value to these social networks. And so it's a bit of a leading question, but I believe the reason that microservices are valuable is the same. It's relationships. If we think about what a microservice architecture is, we take a monolith API and we break it down into multiple little services. And that's brilliant for us as developers and testers because it's easier to reason about those services. They do a very particular job. But actually, the value in those services, once they're broken down, is kind of minimal. They do a very specific job, but until they come together and form relationships with each other, until they integrate with each other, that's when a system is formed. That's when the business value is realized. That's what we're all working towards. So actually, when you think about it, relationships are more important than microservices themselves. Yes, we should test microservices, make sure they're functionally correct, but actually it's the relationships they form with other services that are key, and that's where we should focus some of our testing. But I believe typically we're not very good at testing those relationships. We're quite bad at testing relationships because it's quite a difficult area to test. So if we think about some of the ways we currently test relationships, our first two options are ones that you've probably seen before, end-to-end and integration testing. And I know this is a testing conference, so I'm sure you're all familiar with what these terms mean, but just to be clear, end-to-end testing is where we start at the beginning of a user journey and work all the way through all the different microservices, through all the different relationships to the end. And integration testing is similar, it's just a subset of that user journey. Instead of going all the way through, we pick a part of that journey and we maybe mock out the rest of it around it, something like that. So both of these styles of testing, I believe, aren't great for testing relationships. Firstly, they're slow. They're slow partly because they rely on deployed environments, maybe a long-running test environment somewhere, or an environment that's spun up on demand where you need to wait for these services to be installed and ready to test. But they're also slow just down to the very nature of the tests themselves. We're testing a complete user journey or a partial user journey, and there's lots of little moving parts there that we're trying to test and wait on. Maybe we have to wait for a certain message to be published after we go through a certain part of the user journey. So there's lots of things that slow these tests down. They're also brittle. And by brittle, I mean they produce lots of false positives and they can be difficult to work with at times. And part of the reason for that is the environments they run on, but also the scope of the tests. They're very broad in their scope. So instead of being tightly scoped tests where we're testing one thing at a time and we can have good confidence that what we've tested, if it fails, is actually because of the thing we're testing, with this, it could be any number of things. If it's an end-to-end test, there could be how many microservices being tested at the same time and how many more relationships on top. And the same problem exists with integration tests. Again, just on a smaller scale, just because it's a subset of that user journey. So because these tests are slow and because they're brittle and broad, it makes them expensive. It makes them expensive to run because you have to wait for them to catch up. And it also makes them expensive to investigate when things go wrong. When you look at these tests as a developer or a tester trying to figure out why they failed, you have no real confidence necessarily if it's down to the environment they're running on, if it's down to the test itself, or down to a false positive due to some test code that wasn't able to handle a situation. And even if it is a genuine failure, you've got to dig in and find what service went wrong or what many services went wrong. So these two options are not great for testing relationships. So at this point, normally when I speak to teams, they say, well, what about mocking? Maybe mocking can solve these problems. We can look at the relationships using mocks. But if you think about what mocks are, mocks do the exact opposite. They remove relationships from your test. If you think about how a mock works, certainly the way I typically do it is I go to the service I want to mock, I make a request for that service, get the response, and I copy that into my mock server or into my test pack. Now, instead of my test speaking to the actual service that I want to test the relationship of, I'm speaking to a mock. The relationship is never triggered, it's never tested. Not just that, but because I've made that copy and paste, I'll probably never look at that mock again unless this test starts failing. So they're rarely verified and they go out of date. You get mock drift. And that means that the test can pass even if the mock service has big fundamental changes that would break the relationship if you were testing directly. So when you think about mocks, mocks are not a great way of testing those relationships. So how about contract tests? Which feels like we're getting a bit warmer because the whole point of a contract test is to test the contract of that service. But contract tests have a circular problem. If you think about how contract tests are formed, what typically happens is a team makes assumptions about an API, about how their consumers are going to use that API, how they're going to use that microservice. And then that same team writes a contract test around those assumptions. And it's not surprising that those contract tests then prove those assumptions. So they're circular in their logic. At no point in this process have we spoken to our consumers to see how they actually use our microservice. We've not examined the relationship. We've just made assumptions about that relationship. And that's not to say these tests don't have their place. They're great for checking the versioning of APIs and those sorts of things, but they're not good for testing relationships. In fact, when you think about contract tests for testing relationships, I would like you to think about them more as circular tests because they don't look at those relationships. But consumer-driven contract tests can fix these problems. And the key here is the consumer-driven. We're going to look at consumer feedback. Consumer-driven contract tests test relationships. And we'll dig in a little bit in the next few slides as to how that works, but they do so in a way that's fast. They're fast because consumer-driven contract tests rely on mostly unit tests and mocking. So you still get all the benefits of unit tests and mocking with that fast feedback, but they do so in a way where those mocks are verified by the provider, by the team actually providing that microservice. They can check those mocks and make sure they're accurate and they don't drift. They're also robust. These tests are robust in part because they don't rely so much on environments. So there's less of an issue that could go wrong with your test environment that impacts your test result, but also because they're tightly scoped. When we test using consumer-driven contract tests, we test one relationship at a time. Instead of like our end-to-end or integration tests where we're testing lots of things at once and there's lots of moving parts that could fail, we're just going to test that one relationship. So if the test fails, chances are it's probably down to that relationship and their problem being there in that relationship. So finally, because of these reasons, because they're fast, robust, and tightly scoped, they're also cheap. They're cheap to execute They don't take long to run, and you don't need vast environments to run them with lots of resource and compute power. That's all cost money. But they're also cheap because they're easier to maintain and they're easier to diagnose when they go wrong. When these tests fail, it's easy for testers, developers, members of your team to go in and see why they failed because there's less moving parts. So if they fail, it's more likely going to be a genuine failure. And finally, they're not circular. When we looked at those contract tests, you could see there was a circular logic to them. We weren't speaking to our consumers. We weren't getting their feedback. We might do it occasionally, but it's not baked into the process. Consumer-driven contract tests, the key is in those first two words, they're consumer-driven. You're going to get feedback from your consumers. So I'd like to take you through how these tests work so we have a better understanding. So typically when we test a relationship between two teams, we're going to test that one relationship with two tests. And we're going to go through three stages. A consumer test, which then shares a contract, which is then taken in by a provider test, which verifies that contract. So for this example, if we can think of, and I'm stealing this from an actual team I've worked with in the past, but I just won't mention any names. But if we think about the provider team, let's assume that they're a catalog team. They develop a catalog API, and it lists products, price information, images, that sort of thing. And then the consumer team is an Android team. They work on the Android app that consumes that catalog API and gets all that catalog information, packages it up, puts it into the app so that customers can look at it and get a feel for what they want to purchase. So how can we test this relationship using consumer-driven contract testing? So it starts with the consumer. The consumer is going to create effectively a unit test that uses a mock server. So some of this is not going to be all that unfamiliar to you, perhaps. And that consumer test, those unit tests, are going to contact the mock server for the mocks that consumer has set up. So what types of requests, what type of response are expected, what's in that response body, the headers, what response codes, all of that stuff. And it's all going to go through that mock server. But the key difference is at the end of the test, a contract file is going to be generated. And that contract file, you can think of it like a forensic log. It's going to detail everything that happened during that consumer's test. It's going to detail everything about the mocks, the requests that were made, the responses expected back, the response codes, the response headers, everything is in there. And all the expectations, the things that the consumer checked in those responses, so we know what's important to them. And then the provider has their own test. Now their test isn't a unit test, but it's a fairly simple test in that it takes that contract file and it reads through it. It reads through it example by example, mock by mock. And it looks at each mock in turn and it makes that mock request to an actual running service. So to the actual catalog service, it's going to make that request and it's going to get the actual response. And once it gets the actual response, it's going to compare the actual response to the response that the consumer, the Android team, mocked out during their testing. And if they match, great, the test passes, the relationship has been verified. And it's been verified in this asynchronous way where we've not needed a big test environment or for these tests to run in parallel. They can happen whenever it's suitable for both of these teams. But if the test fails, the provider now has a failing test in their pipeline. They need to go speak to that consumer and talk about why it failed. Maybe the consumer is using the mock in a way they wouldn't expect. Or maybe the provider has changed the feature set in a way that is going to break that relationship. So now we have a way of checking these relationships in an asynchronous manner that allows teams to talk to each other. Because that is probably the most important part of this technique. It's consumer driven. The teams need to talk to each other. There needs to be collaboration. You can't just expect one team to do this. So how could you start using consumer-driven contract tests within your organization or within your teams? So there's a couple of tools out there that use this technique now. I know that Postman can run these styles of tests, but for me, the one I've used with teams is called Pact, and it's an open source framework for writing consumer-driven contract tests. and it supports many different languages. So not only is it open source, which is great because you can have a look and you can see how it works, it's supporting many languages is a really key feature, which really sets it apart. If we think to our example, the consuming team, the Android team, very well might be writing their tests in Kotlin because that's what they developed their app in. But then the catalog team, the catalog API team, may well be writing their API in C#.NET, for example. Well, these two teams are working in different languages. Is that going to stop them doing this form of testing? Well, no, because they can still write the tests in whatever language they feel like they want to write it in, as long as there's a pack developed by Pact that they can use, a framework. But they can still use whatever language they feel as long as they share that contract file, because that contract file is the key. And that contract file is just JSON. And that's one thing to note when you look at Pact. Pact calls contract files Pact files, but the concept is exactly the same. It's a JSON file, and there's a JSON specification on top of it, just defining how it's structured. The other nice thing about Pact is you get a broker. And this broker helps you share files between consumers and providers. One of the things you might have been thinking of as I went through that example is this sounds great, but if we have lots of teams doing this, there's going to be lots of contract files that need to be shared. How can we share these files in a way that scales? So let's talk about that. Let's talk about how we share contract files, these Pact files. So there's typically three options. There's the file system, or there's a bucket, a hosted bucket like AWS and GCP, or the broker, which I've mentioned. So the first option is by far and away the easiest. It's just a folder on your file system. It's just on your computer. You can have all the contract files live in that folder, and the provider test can go to the same folder, get them from there, read them, do what it needs to do. So it's really easy to set up, but it doesn't scale at all. If you've got more than a couple of people working on a project, this is probably not the best solution. I would only really recommend this solution if you're working on a project where it's just you, just on your local machine, developing everything. Then maybe you can use this to get started, or perhaps for proof of concept projects, because it just doesn't scale. Yes, you could check these files into Git and have them in a Git repository, but then you come into problems of naming issues and collisions, and how do you manage historical Pact files? It gets a bit messy. And also there's no overview. One of the nice things about the broker is you get generated documentation and generated diagrams describing the relationships between your microservices, which can be really useful when you want to start describing the dependencies between teams, particularly if you're perhaps a less technical member of the team, maybe a product owner or a BA. It really becomes handy. So the next option is a bucket. So again, like an AWS or GCP bucket, you can just create one of them, have it hosted, and get teams to drop their files in there. And that's not quite as easy as a file system, but it's still pretty easy. You just need to go and get that bucket generated. And it does sort of scale insofar as teams can easily get to that bucket, but it still has issues around collisions and naming problems. And you still don't get that overview documentation, which is really nice to have. So that's where the broker comes in. The broker is scalable. It's a properly designed API and front end for managing those Pact files. So you're going to get versioning, you're going to get collision control, you're going to get little bits around it knowing when a Pact file should be re-verified, when should someone look at that consumer-driven contract file again. You also get a nice overview of the relationships and documentation, all generated based off the Pact files, so you don't have to do anything to get that. That just comes included. And finally, a really nice feature about this is webhooks. What I've done in Teams in the past is I've wanted to integrate these Pact tests with Slack channels so that when they fail, a message goes out onto Slack to the teams involved so they know they need to talk to each other to figure out why it failed. You can do that with webhooks. You can also set it up with pipelines. Maybe you have a Jenkins pipeline you want to set it up with so that you trigger the provider test as soon as a new contract file is published. You can do that using webhooks. But there is more setup. You are going to have to host this internally somewhere, and that means provisioning something or doing something like that. Now, the Pact core team do make it a little easier because there is a Docker image. So if you use Docker, that solves a lot of your problems. but there's still questions to be answered, such as what do you do about hosting? What do you do about authentication? So if you're leaning towards a broker, but the setup is putting you off, then there is a fourth option not listed here, which is a hosted service, a paid for service by the Pact main core team called Pact Flow, which is a Pact broker just with a few nicer features, maybe a bit nicer of an API, a bit nicer of a UI, those sorts of things. So I just wanted to show you an example of some of that nice documentation that the broker generates for you. On the left, you can see the service diagram showing the relationships between services and how information flows. And on the right, you can see the documentation that gets generated based on that Pact file. So here we have a Pact file that's between the zoo app and the animal service. And you can see all the examples of how the zoo app mocked out in their consumer test, the animal service. And so this is really useful. But again, the less technical members of your team, perhaps the product owners, the BAs, who know there's a relationship between these two entities, but they don't know exactly how it's formed. Here in black and white is a real nice set of examples they can go through to help them understand. So what technologies can you test with Pact? We've spoken a fair bit about HTTP APIs, and that's certainly the first use case that most people will think of, but there are others. Generally, when JSON is being passed around in requests and responses, Pact could be a good fit. So if we think about HTTP abstractions like GraphQL, maybe a consumer team wants to check that when they request a filtered response, they actually get that filtered response. And the provider team can verify that they're requesting those filters in a way that makes sense. They can do that using Pact. Also, messaging services. While I've not done it with teams myself, I have seen other teams do it, where if they have a messaging service like PubSub or Kafka that takes JSON messages on one end and pops them off on the other to do something with them, you could use Pact to test the relationships around that. And finally, I've never seen this before in real life, but I did do a bit of research before this talk, and I saw one of the core maintainers on a Stack Overflow question actually mention that if you have a JSON document database, such as MongoDB, if you've got a database that stores JSON files rather than your typical relational database, you could potentially use it to test the relationships there as well. So as much as I like Pact, and as much as I think it is a good alternative for testing the relationships in our microservice, which are so key because the relationships is what gives our microservice architecture its business value, it's not always going to be a good fit. And sometimes you are going to have to rely on those end-to-end integration tests. So the first instance where it's perhaps not a good fit is when the provider team won't write any Pact tests. So if you're the consuming team, maybe you're that Android team with that Android app wanting to consume the catalog API, and you want to write Pact tests, well, you can do that. You can write those tests, you can generate the Pact file. But if the provider team isn't willing to write the test on their side to verify it, then there's no point. You're just adding overhead for no real reason. The one thing I would say to this point is the provider side of the equation is actually the easier side. It's a very simple test to write. It's the consumer that's doing most of the work. So I would perhaps push back on these teams sometimes if they really don't want to do it and ask the reasons why, because it's not that much work. The second example where this style of testing, this consumer-driven contract testing isn't useful, is integrations with public APIs. Now, there's lots of different reasons for this, and it's a little bit nuanced. But if you go to the pact.io documentation, they talk about it a bit there. But for example, let's say the Android team need a particular product to be in that catalog API, and they use that in their mocks. Well, Pact offers you a way of managing state on the provider side to ensure that that product is available when verifying that relationship. But it could become a problem if you try and do that with a public API, because you might affect the users of that public API. So it's not a great idea. And then finally, teams with poor communication. As much as I think that this tool can be used to encourage communication between teams, if your organization has really poor communication problems, then it's better to think about fixing them first before introducing this tool, because ultimately this tool relies upon communication between teams. The technical side of it will only get you so far. You need to actually speak to each other. So my experiences from using this technique with teams. First, the good. There's no environment orchestration. So that means there's less to go wrong, or there's very little environment orchestration. There's no slow and brittle tests because we're testing tightly scoped things. We're only testing one relationship at a time, and we're using and taking advantage of mocking and unit tests, but we're doing so in a way where the mocks are verified, so there's no drift. So if they fail, it probably is an issue. But it's not all positive. There's a network effect problem. While you can definitely try this out with a couple of teams to see if it's right for you, to get a real value from it, you need as many teams as possible bought in, because that's when you're going to start to really map out all the relationships in your system, and it becomes really powerful. There's also a learning curve. Most teams I speak to aren't really aware of this technique. When they hear contract tests, they think of those circular contract tests, which aren't testing relationships, they're testing assumptions. So there is a need to think a bit about how you're going to write these tests. So that can be a challenge. And then finally, another team can break your pipeline. If you're a provider team, then the consumers can now break your pipeline. And a lot of teams don't like that. But when you think about it, that's actually a positive. You want to know when the relationship is broken down between you and your consumers, rather than push something out to production where it could break that relationship for many other users. So to wrap up, relationships are more important than microservices. Yes, we need to test microservices, but relationships are by far more important because that's where the business value comes from having a microservice architecture. So test your relationships and talk to each other. So thanks for listening, and any questions, I'm happy to answer them.
All right. Thanks, Tom. So, yeah, while I'm waiting for questions from Workshop to pop up on my screen, just to explain to others that I'm not actually looking directly in Workshop myself. We have helpers who dig it from there and put it on into a shared document that I can see. So kind of, we have like microservices going on here on a human level.
Yes.
So just to clarify, I'm feeling a bit useless here in a way because I don't have much experience with microservices myself. So what's actually in the contract file or the Pact file? So what does it define?
Yeah, absolutely. So if we think about that microservice does a very particular job. It has a very specific role. And what the Pact file represents is all the interactions with that service that a consumer has. So if we think about that Android team where they have their Android app and they interact with this catalog microservice to get catalog data, well, they have lots of little interactions with that API. They want to know product information like the price and maybe pictures of the products. They want to know maybe a little bit about stock information. Well, they're going to test that in their unit tests using these mocks. And that's exactly what's in that contract file, is all those little interactions which can then be verified by the provider.
Mm-hmm. And you also brought out that if the provider team won't write Pact tests, that's kind of a no-go situation. Do you have any experience convincing the provider teams to do that?
Yeah,
and
absolutely.
Can you share tips?
So not every team wants to do this. They see it perhaps as a bit of an overhead. When they've already got end-to-end tests and integration tests in place, why bother using this new style that's unproven? So the way I've typically gone about it with teams is to try and get some pairing time with them if I can, where I can help them in the initial steps of getting this test up and going so they can start to see some value. Also show them some examples from other teams if we've already got one. So one of the things that I did in a previous project is we got a simple proof of concept working between my team and also a team where I knew they were open to the idea so that we could prove the value. And once we had that, we could then demonstrate that to other teams. So a bit of pairing, and if you can, finding a friendly team to set up a proof of concept with where you can demonstrate the value is definitely key. But on the provider side, it's such a simple test as well that once you start pairing with people, I think some of those concerns tend to dissipate because most of the work is on the consumer side. The provider side is one test which says check the relationships for everything with my service.
So that is actually interesting. So that to test relationships better, you need to have better relationships.
Yes,
Also,
yes, another circular
the whole
logic.
topic is so full of keywords that made my juvenile brain go for very bad puns, but I will hold back on those.
Sure.
Anyway, now we're having some questions from Workshop as well. So, do you have any tips related to versioning the APIs?
Yeah. So what you can do with Pact, and I don't know about other tools, but I'm sure the other tools probably support this, is you can include the versions of the mocked requests that are being made and the mocked responses. And Pact will keep, if you set it up with, say, the broker, it will keep all the different contract files and it will version them. So what you can do is you can say, okay, I want to check not just the latest contract, not just the latest relationship, but back when we were version 2 instead of version 10, I want to make sure that that relationship still works. You can roll back time and go to that Pact file that was appropriate at the time and test using that against that version of your API. Because if you're versioning using headers or in the URL, then it should all still be in that Pact file.
Mm-hmm. All right, thanks. Then another question from Workshop. You're talking on microservice level, so kind of inside the same product, but could this work also on a service provider or integration and integrator and customer level too?
Yeah, potentially. So, I mean, my talk was very much focused on microservices, playing buzzword bingo, perhaps. Um, but you can definitely use this with more monolith style APIs or just with those service providers and consumers, absolutely. As long as there's JSON being passed around and it's being passed around using some of the examples I showed, like HTTP or via a message queue or something like that, there's potential to use Pact. I wouldn't say it's a golden bullet. It's not going to work in all situations, but it's definitely worth investigating because if you can get it to work, it's a much nicer way of testing relationships than some of the others we talked about.
Mm-hmm. Right. So I'm not seeing any more questions from Workshop at the moment, but we still have some time left. So. Yeah, and also this is, the first afternoon slot, so after lunch it's a bit,
Yeah, everyone's full from lunch, a bit tired.
could be that why not too many questions are pouring in at the moment. But other than that, yeah, I mean, for me personally, it was such a well prepared talk that it kind of wrapped itself up properly. So.
Thank you
Maybe
very
that's why
much.
there aren't
Thank you.
many questions. Okay, there's another one coming in. So I think there were multiple ways to store the Pact files. Where are these stored in your project?
Yeah, sure. So there are multiple ways. As I said at the time, you can store them on file system. You could store them perhaps in a bucket or in a Git repository, which is kind of a subsection of the file system. And you could also use a broker or a hosted broker using Packflow. For the projects I've worked on, we've used the open source broker and hosted it ourselves, partly because it's free. So it's an easy solution. You can just get it from GitHub, host it. And if you're comfortable with doing that, then that's fine. On projects I've worked on in the past, we were using Kubernetes and Docker. So it was dead easy to take that Docker image and just spin up the service, host it, and away you go. So that's where, if I was picking and it's a proper commercial project or even just a reasonable size project, I'd be looking at the broker.
Okay.
Yeah.
All right. So maybe I don't know. Something is coming to the file. No, nothing.
Okay.
False alarm. But
Cool.
anyway, thanks again, and like I've been saying with every speaker thus far, this would be the point where I would hand you a gift bag and we would have an applause, but it's just us here, and everyone
I
else
know, it's so
watching the
strange.
stream. So it's really weird. But we have made gifts for all the participants, and those will be arriving in the mail at some point. So you will get a Nordic Testing Days themed face mask.
Nice, thank you.
If hoping we won't need those too much in the future, but hey, at least we have them. So
Yeah,
when
absolutely.
we
I
need
can't
them,
wait to get out into the world again.
yeah, we're all waiting
Absolutely.
for that. But anyway, so then I think we can actually take a 5-minute break in this session and be back in 5 minutes. So
Cool.
thanks, Tom,
Cheers. Thanks
and
for having me.
have a great rest of the day.